Today's topic is going to be era of containerization. Most probably why it is important for you guys to understand about containerization, the benefits of it, and generally what exactly is containerized. I mean, what is container? I mean, everywhere wherever you go, irrespective, you are talking about AWS, you're talking about Google Cloud, or even nowadays, even on-prem. Uh, Container is like the go-to tool, the first technology which anyone will always or any tech talks. So feel free to reach out to me if you need any help or any input from my end. This particular today's topic was first to cover the cloud native CI/CD pipeline. I will take that so we can focus complete and more focus on the theoretical part because it will be easy to understand in the morning rather than in the afternoon. So let me cover up the theory part of the containerization and let's get in the basics of why, first of all, what exactly all these different jargons are: virtualization, containerization, Docker, Kubernetes, how this floating dots connect with each other, and why you should be knowing about it. So let me first start from very basics. Okay, let's assume that you don't know anything about it. Let's start from ground zero. So first, the entire thing, right? If you go back completely into old days, there was something and data center, what you guys have in current universities. Also, you will see you have different network, different computers connected in LAN. Then you have a data center around it, a small data center based on the size of university or size of organization. Some may have a big entire floor itself as a data center. It varies from use case or the business one, right? In case of the old traditional way, the biggest problem is licensing, management, operational. It was very overhead and even not cost effective because you have to procure the hardware, you have to maintain it, blah, 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 many things. Right? Simple. I mean, for you guys, it's very simple to understand. If something goes wrong, right? If let's say your one of the desktop is not working or one of your LAN went just goes down, right? One of the particular switch, it's all over dark. Like you cannot do any labs, you cannot do anything. You have to ensure that there is someone from IT team you call around, which just check the cables and all. Just think of the second direction. If you want to set up a new lab, the kind of overhead is very higher, right? You have to, let's say, minimum, you have to get the computers. You have to set up all the networking cables. You have to connect a switch or a router for that lab, plug all the cables to it, right? The cost, the time that it takes to set up, and the effort to maintain, it's much more higher, right? So that's how from people moved from the actual physical traditional data centers to virtualization. Now, what is the understanding or what are the advantages? Why people move to virtualization? Okay. First, very simple of it, right? I've written many points around. Again, I'll try to narrow it down or simplify it for you guys. Uh, why people move from virtualization, from physical hardware data center to the virtualization part of it? Very simple of it. Now, if I mean many people, as Sanchit mentioned earlier, many people would have done the demo, or many people are already doing the demo, right? Worst case scenario, your EC2 got corrupt, okay, or it got crashed, it got deleted. How much time it's going to take for you to spin up a new one? 5 minutes, 10 minutes, or max 15 minutes, based on how mature you're working on AWS, right? Not more than 15 minutes. Do you think is the same experience what you get when, let's say, you are setting up a new lab in your university? No, right? You minimum will take 15 days to set up, and that same thing what you can do here in 15 minutes. And if you automate and everything, it's just 5 minutes. So the time you can see the difference. Second, cost. I mean, it's very transparent. Here you're paying for 15 minutes or half an hour or 1 hour what you're consuming, which will be max $1 USD. And there, even for 1 hour, you have to set up everything, connect, networking, and all other stuff, right? So you can see the effort and the cost and the time is much more compared to virtualization. So that's the biggest stuff. Third is the cloud. The boom of cloud blended very well with virtualization. And that's how the different offering of Amazon, right? Or any of the cloud, pay as you go, elastic modeling, elastic pricing, or scalability. Those all things cherry on a cake was for virtualization because cloud very well integrated and adapted the entire ecosystem of virtualization as the backbone of it. And that's how virtualization become very boom in the market. Just give me 1 minute, then I'll answer your question. I'll go towards your question. So that's how the entire virtualization came into the market around it. And then you get different things. You don't have to wait. I mean, it's very cheap. You don't have to do any sorts of like hardware maintenance and all. The investment, the upfront investment is very simply negligible. It reduces further. Then you can do lots of automation like infrastructure and code, what we understood yesterday. Those all things you can do any sorts of automation with Ansible and all. That not only gives you from terms of the savings in terms of cost, effort, and time, but also brings more of operational excellency. That's how virtualization become talk of the town once people started thinking on the cloud part of it. There's a question. Moving towards the virtualization. So yeah, I think we were comparing around the traditional physical setup versus the virtual part of it, and how exactly that helps, right? In terms of the upfront cost investment to the savings or reduction in the time, cost, and effort. That's how people easily adapted towards virtualization part of it. And the biggest thing is accessibility from anywhere. One of the major topic why people adopt cloud is the accessibility part. If you talk about the physical data center, it is very difficult. If you're working from that co-location or the surrounded co-locations, then only you can access it, or you have to do VPN and all this stuff. But the networking becomes very complex. But when you go towards the cloud, the best part is you can access it from anywhere, from any part of the world. And that's how most of the people adopted cloud in this COVID era very rapidly, because of accessibility. You can access it from your home, you can access it from any coffee center, you can access it from US, Canada, UK, any part of the world. Really doesn't matter. It's universally accessible, omnipresent. So that was the advantage. Any other questions on virtualization before we move forward?
Yes, I have a question.
Yeah.
See, my question is that as people are moving towards this container technologies, right? But what I feel that it is not good for the standalone machine, right? We must have that good infrastructure, hardware infrastructure. Then and then we would have a benefit of this kind of technologies. Am I correct?
So yeah, I will explain you an upcoming slide because I have that differentiation, right? Virtualization versus containerization, where I think that will be the right spot. I'll answer the question, right? What exactly and how people are looking forward. Would that be fine?
Yeah. Okay.
Yeah. Any other questions on specifically on virtualization? Cool. Moving towards the next. So I think yes, sir just mentioned about the problem or the kind of compute what you need for enabling this advanced or modern era technology. Before that, I want to take this one slide is what exact was the problem of the virtualization, and which is very easy to address, right? You have a physical hardware, you have a hypervisor, and then you have OS, app, and VM. It's a very simple example of virtualization. I mean, I want to make it very simple. Is the EC2 instance, which you guys are going to spin up for Jenkins. Now, if I talk about same example in EC2 correlation, physical hardware hypervisory will be taken care by AWS. I mean, AWS will take care of it. Even the basic OS or Linux, Windows, or anyone or Mac even now, AWS also do supports Mac. They will give you the OS. The app, let's say in our case, the app is nothing but the Jenkins. So any EC2 which you're going to spin up, you have to spin up this VM box, which consists of OS and application, right? OS and application, OS and application. Now think of you have to spend hundreds of EC2s. The time it's going to take is tremendously more, even if you have automation and other stuff. And the worst case, let's say you're running this entire 100 EC2 instance in production and 50 of them got crashed. 50 got crashed. That simple means that you have to spin up that 50 again. And the time it will take is the same, right? Because you have to, again, Amazon will take some time to spin up a new EC2 on hypervisory, deploy OS, ready all the patch and all, and have everything ready. And then you will do an application on top of it. So again, the time is going to be the same. That's exactly what's the problem. And the biggest thing is OS licensing, right? In cloud, it is very easy because you're working on a pay-as-you-go kind of a model. But let's say there are certain private clouds are also available. We generally, I mean, don't focus more on private cloud, but there are certain companies, regulatory companies, which heavily invest in the private cloud. There are XYZ private clouds are available. In that, you have to bring your own OS, bring your own license, like how you have Windows machine in your lab or in your laptop, that Windows OS. the licensing is also the cost you have to bear. So you're not only paying the cost of virtual VM to the cloud vendors, but you also have to bring your own OS license. So if you're spending, let's say 100, you have to bring the 100 licenses, like the node 100 node license. So the cost is more. Still, there is, I mean, better than what you had in the physical data center, but still there is a liability of OS. That was the biggest thing that comes up. And again, you need to maintain the OS for all the hundreds. You need to operationalize for all the 100. Those still remains the same, right? So you move to a better situation one step, but again, you're not fully there. There are gaps to it. There exactly the solution comes is the containerization. Containerization is simple. Example, if I talk about the icon which is here is like a hotel. Now in hotel is, it's not like a bungalow that only one family will stay in that bungalow, rest cannot be shared, right? It's like a hotel. It's built one time, and the rooms that can be occupied for all the guests unless there is a capacity in that hotel, right? So now if you take the differentiation between the virtualization and containerization is, it's not only one family can stay even though they have a space and other stuff, right? If I talk about, let's say there are only a couple which is staying in a bungalow, right? A 50 3 storage bungalow, right? For sure there will be space which they can share, they can rent and XYZ, right? But they cannot do it because it's a private, their own privacy and bungalow and all. Whereas if I talk about an hotel, even though there is a 10 storage hotel which has like 100 rooms, unless and until all 100 rooms are occupied, you can keep allowing guests to enter. Once guests get checked out, you can allow new guests to enter, right? So you can keep flowing the traffic until you have a capacity in there. And again, the infrastructure remains the same. The hotel building remains the same. The other facilities remains the same, right? All the costs which go on to build that hotel remains the same. That comes the containerization part of it. If I quickly move to the next slide. So here exactly is the containerization part. So if you see here, the biggest difference that comes in containerization part is the OS is below the containerization where you are having the other stuff. The hypervisory layer remains the same. The OS is shared across all the container application. So let's say if you're deploying, you have a very big machine, right? When I say big machine is like somewhere around 16 GB RAM, 16 GB RAM, or let's say about 24 GB RAM. If you have a high compute applications, you can split based on your compute capacity and deploy all the applications on top of it. And that same OS level, same hypervisory, same setup of the host, which is, let's say, even in case of EC2, remains the same. And you have to worry less about patching and all of the stuff because it's going to be one machine versus the different numbers of applications. And yeah, I think there was a question from in terms of the standalone machine. I would say it exactly what you mentioned. It's a spot on thing, right? So there we have to be very effective, as I mentioned yesterday also, right? In the last 2 sessions, I mean, given in this scenario, given in the type of business application, it's very important that you select the right technology. Like for a very example, let's say very simple is you want to run an hello world Java application, right? Now, for that you should not spin up a container, right? Container is a good solution when you have a very larger target base audience, when you want to reach out to larger target audience, minimize the infrastructure cost, minimize the operational overhead. Then it makes sense for containerization. And one more benefit that comes with the containerization is the cloud agnostic part. Like since Docker is a universally adapted, you go to X cloud, Y cloud, Z, or even on-prem, you can take that Docker file, which is a core, and you can move across anything. So same Docker file, which can run in your laptop, the same can run on an EC2 instance on the cloud. So because of cloud agnostic, the scale, the volume it can scale, minimize operational overhead is what container picked up in the market. But again, if we think about that, we have only one standalone application like in Hello World or a simple app. We should not do container because it may act as an overhead. Overhead in terms of what you have to do is you have to set up container, you have to Dockerize it, write a Kubernetes, Docker files and all of the stuff, set up everything and have ready. By the time in that simple time, you can already finished up your experiment in virtualization mode in a simple EC2 instance, right? So very simple of it. And again, even when we are working on industry, when it comes to the dev environment, or simply if I talk about the machine learning, ML engineers, when you talk about the production, all the machine learning models will be containerization. But if you talk about the development, nothing is containerization because of the same thing. First, we are not sure the code is yet there. There is multiple iterations that will come up. Two, they don't want to lock themselves into very platform and all, because they want to more focus on the functionality part rather than scaling, because scaling should be in production. 3, they want to have multiple trainings in training and other optimization, tuning, and all of the stuff. That's why to focus purely on the business application, they take a high compute and focus on that. Once they move towards the next step, as a part of CI/CD, they package their ML model into container files and release in prod with containerization. So that's how people generally also do it. And that's not for machine learning, that's how people, even the software engineer also does the same thing. Whenever they normally work, right? Any software developers, at day one, they will not containerize their application. Let's say, for example, they are building a Spring Boot Java application. They are not going to do a containerization on day one. They will do it as a part of their CI/CD pipeline as an automation when they are building it. As a part of that, they will be doing it when they're looking for the higher environment. Does that answer your question, Parth sir?
Yeah.
So that's exactly about the containerization. And the biggest difference that comes up from the virtualization and containerization is the sharing. If you see the difference, right? I think there should be, yep, there should be a difference. Yeah, I think it's not there. There should be a difference is like the OS layer. The OS layer here, if you see, it's what is being shared across app 1, app 2, app 3. But if I go back few slides, you can see the same app has its own independent OS. Now, some application are very simple, like in Hello World. Some application may be very complex, like an SAP. So there is a space where you can share, but that sharing is not possible because each one has its own box and own privacy. So that's how containerization helps us to share, have more of sharing of the base layer and simplify the entire deployment of the application by focusing only specific to that application rather than worrying about the host machine details like the OS, networking, and all other stuff. I think there's one more question what we have. Yeah, Amit, please go ahead.
Hello, Sanchit. My question is how security is managed in containers?
That's a very good question. So again, when I say it's a sharing, right? Sharing, that doesn't mean that one application like this app 1 can easily talk to app 2. You can see there's a proper wall what we have, right? So Docker, when it comes to spinning up a Docker, right? That was a very basic thing. The Docker was also taught the same thing, right? That, okay, hey, we are going through having a sharing. Now, it might be possible that you're deploying app 1 for another client, app 2 for another client, app 3 for another client. How we are going to ensure it? So first, there is a proper networking is there. Like if I talk about in case of AWS, how we have VPCs, and in VPC you can have firewall rules and keep the machine segregated. Similar what you can do in Docker. In Docker also, there are things on terms of security, in terms of networking. You can isolate the complete two applications running in the same container to ensure that they do not talk to each other unless you tell them. In terms of the storage, in terms of the networking or / communication, you're completely working in an isolated machine itself. When it comes to like app 1, things like I'm working in a completely isolated machine compared to app 2.
Okay. So how suppose if I want to do the synchronization between two apps, for example, over here in the slide there are many apps, and I want to do the synchronization or maybe the concurrency, sharing of the messages or sharing of the resources maybe. So how it happens?
Correct. So let's say if you want to, when it comes to, so first is when it comes to, let's say sharing, right? They want to interact with each other. Very simple is you're building like an web application, okay? A complete multi-tier web application where you have a front end, you have a back end, and you have a database. App 1, app 2, and app 3. First, you can define your own networking setup. That's one, that okay, in which port, which app should be able to connect, right? There is something called as ingress and all other stuff, which you will see that app 1, in which port app 2 should connect, app 2 should connect to which port. That same remains the same, right? That's one. 2 is around the entire opening of the ports. So when it comes to the ports also, when you're running any Docker command, which port it should open, that also you specify. And 3, when it comes to sharing, let's say for an example, keeping this web tier aside, let's say you have same application running app 1, app 2, app 3 are the replicas of the same application, and they want to read the same file. Then there is something called as persistent volume. Persistent volume is this shared EBS volume, shared volume of the host. When you, let's say if I talk about an example of EC2, now EC2 has its own volume, EBS volume, or whatever the hardware or volume what we attach when you're launching it. That same volume you can plug to app1, app2, app3 as a persistent volume via which they can interact like how they have, and they can share across the data around it. And then on top of it, you can have things like Redis and all other stuff which you can communicate. I mean, in short, which I mean is like a queuing.
Yeah. This is what I have heard actually. It is somehow related to queuing. So yeah.
Yes.
Thank you.
That is a different way around it. And again, Docker is also somewhere going out of the picture now, and Kubernetes is becoming a talk of the town because of the same reasons. Not only the kind of an enterprise orchestration and management it provides for the Docker containers, but the kind of security, the kind of sharing, or the kind of other complex networking and all it supports in a simplified way. That's the best part of Kubernetes, which we'll see in upcoming slides. That's how you would see people slowly and gradually, everyone has been moved out from Docker towards a container side. Yes, sir.
Yeah, still, I feel that if there is no modularization in the application, this means that application is monolithic kind of. Then the people should go with the Docker rather than going for the this Kubernetes and all this. Am I correct?
Yes, that's a good point. I think what you mentioned around this stuff, I would honestly say, even in case of monolithic also, I won't even suggest Docker to go. Couple of reasons, right? Let's say for an example, the whole part of having a monolithic. Now, if I take a very simple CURD operation, right, for any database. Now, if you have that entire, all the endpoints packaged in one Spring Boot application, you're not going to get the best benefit out of it. If something the best thing of containerization is the kind of fault tolerance, the kind of scale it can give on each application. Now, if you're deploying the same monolithic application, first of all, it's going to be heavyweight compared to split into different endpoints and different sub packages. One package is going to be heavyweight. That's one. Two, if that one got failed, for sure, then entire all the APIs are going to fail. The same thing which you normally see in monolithic. So ideally, I would say the always recommended way is that even when you're talking about having the monolithic architectures, there are two parts of it. If there is very traditional applications there are certain applications which are very traditional. The only option, you cannot move to microservice. The only option is you break and revamp complete that application. If that is the case, then you go for sure with containers, not for Kubernetes. For sure, container is a go-to tool if you want to still go and use a modern technology. Reverse, if there is a scope where you can redesign and re-architect as microservice, then for sure you should first go to microservice, and then you should look forward for any container solution, whether it's Docker or Kubernetes.
Okay.
And personally, I've seen, I think that's a very valid point. I've also seen that many, when we are solutioning it, there are many applications that are very traditional in nature. Like if I talk about, like in the first session, which I mentioned, the financial applications, right, which are built like in 1980s or even before that. There is no way you can break that architecture, break down into microservices. It's not meant itself. Or if I talk about the old school, like COBOL and other stuff, right? There is no way. I mean, they doesn't even support. There's no other way you can do it, right? Even for C++ also. In case of C++, I've done one of the experiment where there was like a complex analytical algorithm was built in C++. There was no other option for me outside just going for containerized solution. We were not able to make any changes. Neither we were able to re-architect to microservice because there is no scope. The only thing is I just revamp, just discard what is there in C++, rewrite it in Python, which is very time consuming. But if I want to deploy that in a fault tolerant and highly scalable mode, as Sir just mentioned, the best option was that you containerize, make some small changes so it is compatible with Docker, and deploy in Docker and put it on EC2 or on the cloud. So there are multiple, as I said, right? There are multiple parts are there to solve a puzzle. You have to understand what is the current scenario and how your application can work to reach to that end state of the puzzle. Any other questions?
Thank you.
Cool. Moving towards the next, right? Containerization holds the same good properties of VM. I think we already touched base in that stuff. I think Amit asked the same question around the security, the isolation between the application. Right? Those all still remains the same. I mean, there is no change when it comes to VM part of it. They are always the same. The best part, which is there, right? In container, even let's say some reason the container got killed or it died, it's like the same VM kind of stuff. You will lose your data. I mean, the data will not be persisted and all of the stuff. So it still remains the same, or what you're going to have around it, the processes and all of the stuff, like how you have the Unix process and all of the thing with the PS command, that will remains all the same. And it can be stopped, like how we can stop the EC2 instance. Similarly, it can also be stopped, given said that if had a shared drive attached to it, if you want to save the state of it. If it is something like stateless, that doesn't matter, even if it got lost, then for sure you can just normally design it without worrying about this many things. So those about the container part of it. Let's quickly run through the difference between the VMs and containers. First point, image size. When I say image size, is the entire package, the entire deployment package what we have. In VM, it is going to be, let's say if it is 1 GB is your packet size. In container, in VM, it's going to be 3 GB. Why? Is because when you're talking about the containers, in containers, the package is only meant of couple of Docker libraries from terms of networking and all, and majorly heavy lifting your business application. Now, we cannot do anything of business application. If it is complex, it is complex. But in case of VM, you already have that application plus operating system plus other drivers of the OS which is required. So that makes it 3x of the current setup. That's a big difference in terms of it. This size, someone might think, okay, we have a cloud, we get a good speed, then how does it matter? Exactly, that's the right question. The problem that will come up is when you're already in the production, and let's say one of your node got crashed and you want to spin up a new node, this 3x will hamper you at that time, because you need to have that machine running in less than a minute time, so you can continue working and continue serving the traffic to your end customer. So such smallest deployment package will help you to spin up your application faster, which becomes very difficult when you have the larger stuff of it. That's one. Two, the boot time. Again, as we know, when you're talking about setting up from everything from scratch, like OS, device driver, spinning up the virtualization, HVM, and all of this stuff, it's going to take more time. Like you can understand, right? Spinning a Docker container, I mean, once a Docker is already set up, spinning a Docker container is less than a second. You have to run just Docker run command. If the image is already there, it's going to be less than a second. Whereas even though you have the package, the build package ready, but in case of EC2 instance, bare minimum, it's going to take seconds. Like 10 seconds is minimum, because you not only have to have the package deployed, but first you need to launch the infrastructure part of it. So in container, since you already have the device driver and OS safe, it's much more simple. Compute overhead, again, remains the same. In computer overhead, in terms of VM, it will be depends on the application, right? So it will be greater than 10%. In case of container, it will be less than 5%. Disk IO greater than 50%, negligible. It depends on the negligible perspective, right? Again, the computer overhead and disk IO, I won't say this is very subjective to your application. It's not a general kind of a comparison what we have seen in the image and the boot time. It is very subjective what kind of application you can pick up, right? To be honest, I've seen application in terms of computer and disk performing better on VM compared to containerization. The same point which I think initially was also asked, that why we should go with containerization when we have a standalone application. You have to design or select the container, your base node, considering that you know how complex your application is. If you try to deploy an SAP kind of an application on container or an Hadoop platform, right? Even Hadoop provides an Docker file. If you try to deploy an Hadoop platform in a very small machine on container, it may spin up, but the performance is going to be very bad. You will see the computer and disk is like almost 10 times more than what you are seeing here, right? Generally. So be very sure that these are very subjective based on the application. Isolation is good for sure. In VM, we know there is no other stuff. You're running one person around it. In case of isolation container, it's okay, it's fair, because you are going to share across it. So if you don't properly define your networking and all, there is a high probability application can interact with each other. Security, low to medium, medium to high. Low to medium is generally because in case of VM, the security is low because people don't focus. It's like a 1-to-1 kind of a ratio, like for one VM, one application. So they don't really focus on the OS level, I would say, security. Overall, on the VM level security, like security groups and all of this stuff, people generally do take care of it. But if you talk about the containerization, Docker itself provides the security of isolations and all that makes it medium to high. So even if you don't provide any security outside networking, Docker themselves can take care of that. OS flexibility, excellent. OS flexibility is poor because containers, again, you need to be very sure there are very limited image size available, like types and categories of image available, Alpine, Ubuntu, and all of this stuff, because they try to make application as small and as fast. So there are very limited support available on OS. In case of VM, it's very excellent. You can spin up Windows, Ubuntu, any versions of Windows, or even Mac nowadays. So that's the one. Management, for if I talk about VM, it's excellent. For containers, evolving. There exactly, this was the biggest point where we saw people adapted to containerization, Docker Spam, or other tools in the market, which we will learn in the upcoming slides. Last, impact on legacy application. Impact on legacy application is low to medium, and it's high. This is again very subjective on type of the application. If your application is very tightly coupled on HVM, hypervised, there are certain business applications which requires very specific hypervisory and all other OS hardware kind of details, then never think of going with containerization. VM is the best thing. There you will see the performance is not improving. It will degrade over a period of time. So that's about the difference between VMs and containerization. I think I see a question. Yep. Yeah, Pritesh, please go ahead.
I think third last point, can you elaborate more? OS flexibility container, how is poor compared to VM? Yeah.
Yes. So basically, in case of VM, okay, now we're talking about your laptop as a VM. Now, in case of laptop, you have a flexibility that you can deploy Linux, you can deploy, let's say, Ubuntu, you can deploy any other OS, you can have Mac. If you're having a Mac, you can deploy any Mac, any version of OS, right? It's very flexible. It's on you, based on your requirement, based on what you're teaching or what kind of usage you have of your laptop. You are very flex. You can say, no, I don't want to upgrade my laptop with this patch, or you can say, no, I want to upgrade with my patch. You can even customize your OS, right? So many organizations or many colleges, you will see certain operations of a OS are not allowed. Okay, like very simple of it. Any support to a pen drive, like from a driver perspective. I mean, hardware you need to for sure block from DOS, but some additional settings and configuration which you can do from a flexibility perspective. That is very excellent in VM because you have complete ownership on that. In case of container, Docker holds more of the ownership on it, so it is very poor. The what image you get, package what you get from Docker community, that's only limited support you have. So very simple of it. Mac, currently Mac is, I mean, you can run Docker or container on Mac, but Mac as an imaging container is not supported. So let's say for a certain application which are Mac specific, you're not able to use it. So that's what OS flexibility means. Problem is, if you see the Docker file, right? When you're having a Docker file, in Docker file, you're directly importing the libraries, right? If you don't even have the library, you will not be able to import it, correct? So that's exactly what I'm saying, that in case of container, in case of VM is like a universally you can install. Things are available in the market, you can install. If you want to do it, you can do it. In container, you're purely relying on the community, which community is giving it. So as you mentioned correctly, right? That let's say I want to deploy an Nginx. Fine, Nginx image is available by community, Docker Hub, so you can do it. But let's say in case of that community itself is not providing Nginx, then you will not be able to do that. Similarly, like for example, if we talk about an VM, if Windows machine OS itself is not coming, Windows, let's say next 2 years down the line, Microsoft come up and say that, okay, I'm not going to distribute OS as separate entity, like how Mac has, right? Tightly bound. So Mac just always say that, okay, my operating system will always run in my machine. If you don't have my machine, you cannot install Mac. So that's exactly the problem with container, that you can do anything which you want. That's not the problem, but the support is limited. What you can play around with that box. And whatever you have in that box, you can do best of it. So however we say that, okay, we can build our own Docker and all, it needs to be compatible with this engine that interacts for any resources from this host OS. So if you pick up, let's say, for example, you need a particular port 80 for the host OS. From here, you need a port 80 because you want to open it to the universal. So application will not directly talk to host OS. Application will tell you Docker engine, hey, I need port 80, like port 80 colon port 80. There, Docker engine will translate and will tell host operating system that, okay, for app 1, I need port 80. Please allocate port 80. So that's the, I would say, plus and the minus point of it. But yeah, I think as we were talking about, I think we already are going today well session, and the big part of it, right? The provide isolation about that, help them to share the OSs, deploy any container you want to play around it. You can do the same. So before we move ahead to the next slide around the architecture, any other questions around the difference on the virtualization versus containerization? What is an containerization, or any other questions? Moving towards the next, Docker engine components, right? Now, what exactly we have talked about the Docker and other stuff, right? So how exactly the entire Docker architecture is. So before going to the theoretical part of it, this is same. I mean, theoretical is more about the definition, what is each component and all. High level, this is the Docker component. There are 3 states to it. One is the client, one is a Docker host, and one is a registry. Now, in case of normal scenario, you will see if you talk about any production setup, Docker host will be running in another instance like an EC2 or some other where. Client will be in your machine like a CLI from where you can run the commands. And registry is what more like a Docker hub or like a GitHub in normal scenario, right? When people have built their own, I mean, some companies would have already sell their Docker images. Some community would have built their own Docker images. You can also store your private images. Those all registry. From registry, you will get the images, which you can put it into container. And the entire brain of this all setup is your Docker daemon. This is a high level stuff before we zoom in into the theoretical part of it. Any questions on this particular flow?
Yes, Sanchit, I have one question. So are you going to cover to map port in this session? So I will wait. Otherwise, I just ask question right now.
So in case of map port, what exactly you're looking around like?
I think as per my experience, I have seen that we have to add one line in a Docker file that's
-T.
yeah. So that we have to map 80 port with other port for different containers, right? So
Yep.
I just want to know more detail about how they are working when we map the port from 80 to outer users they are accessing.
Correct. So exactly how it works, right? I mean, I'll open up. I've skip the slide of the demo, right, for the session. But I'll walk you through in that after the session around how exactly things work, right? For now, I think let's go with the normal flow,
Sure.
and
Okay.
I'll get back to your question around the -P flag, the port flag. So when it comes to the Docker components, we have 3 different, as I mentioned, the big actors or big different components around it: client, Docker host, and registry. Now let's understand what exactly is a Docker client. Very simple of it. It allows you to interact with the Docker. Very simple one-liner, right? As I mentioned, Docker client is more like a CLI. A CLI, a command line interface, or any medium via which you can access your Docker host. Docker host provides a complete kind of a package where you, I mean, anything what your container needs in terms of images, in terms of networking, in terms of security, in terms of storage. This Docker host provides everything. The same example, if we go back, this is a Docker host in short. Like this box, what we can refer as a Docker host, where you have host hardware, host OS, Docker engine, and all the application. This in a simple way you can refer as a Docker host. And then there are different actors in that Docker host what you have. So in Docker host, the first important thing comes up is a Docker daemon. Docker daemon is like a persistent background process. It's like the brain, as I mentioned, right? The core master or the brain, which interacts the request from the client, or whenever you want to do any operation, Docker daemon takes care of all the stuffs. You can interact with Docker daemon APIs. Now, what that means is, let's say I want to run a container, right? I'm not going to directly neither I know which is a Docker host here, nor I know which is a container, right? Or nor I know which image from where I need to pull around it. Like when I say image, that doesn't mean the name of the image, but the exact physical location from where I need to download, right? So what exactly, when you say Docker run, you as I think Sandeep also mentioned, you provide different things. You provide the image name or other parameters to it, like port and all, right? You don't exactly give them the URL that, okay, hey, Docker daemon, you go and download from sanchit.com. There is some Docker images there. You go and download from it, and then you spin up in container 15, and then you map on top of that container 15, you map, like, say, security 30th number rule. We don't do that, right? We just only say Docker run hyphen image, let's say hyphen name and hyphen port. That's what we just do. Behind the scene, when you give this command, it's in the form of an API, goes to Docker daemon. Docker daemon executes that. So Docker daemon knows from where is the repository there, what is the URL of that repository, then it search based on the name you give. In that hyphen image flag, what name you give, like image, let's say nginx : blah blah blah, that version. There exactly Docker up goes and figure out which image, which version it's there. Then it stores in an image repository which Docker daemon holds internally in the Docker host. And then it spin up a container. If it's successfully able to identify the image or locate the image, then it spin up the container if there is a space available in that Docker host from terms of the compute. That's about the main core part that comes of the Docker daemon. Any interaction, anything which is Docker needs to be taken care, it is done via daemon. Whether it's maybe talking to the host or operating system, whether it's maybe downloading any image if it is not present in the cache, everything is done by the Docker daemon. So that's why Docker daemon is very important. Next is the Docker image. Docker image, if I explain you in one line, is the compiled image. In short, we generally refer as an OSI file, right? Image file when you're downloading or installing any operating system. In a normal Windows also, you get an image file. So that exactly is the image file, the compiled, compressed package of image, which is there in the repository available, which Docker daemon download and cache into this image store. When you're spinning, let's say, let's say, for example, now there is a 2 Oracle Nginx is available. Cassandra is not there. So for example, when I say Docker run and spin up Cassandra, so Docker daemon is going to first go and check, do I have Cassandra in my cache? If the Cassandra is present, then it's going to directly take it from this image. If the Cassandra is not there, then it will go to registry. Again, Docker daemon just not only check the image specifically on the name, but even on the major and minor version. Let's say, even if there is an Nginx, for an example, 6.2 image is available, but you specify 6.3, still it's going to go in registry and get that. And you can easily, if you go and interpret the logs, you can easily identify that Docker is downloading different layers of images. There is a word called as layers. Layers is like the breaking down the chunk of the image also. So if, let's say, you have a bigger application in a Docker image registry, it's not going to download in one form. It's going to download in a different chunk format, and each chunk is like a layer. So you will see when you're doing that experiment, you will see layer 1, I mean, out of that 10 layer 1 / downloaded, 2 / 10 downloaded, 3 / 10 downloaded. So that layer is nothing but the chunk part of it. So that's about the image. Next is around a container. What exactly is a container kind of a stuff, right? Container is a runtime instance of an image. So it's like very simple of it. If I talk about how exactly Docker works, it's a similar line. When you talk about any sorts of in the operating system, what we have, right? You have a program, you have a process. Program is a static file which is there on your hard disk. Unless and until you compile and load, then it becomes a process. Similarly is what you have here. There is a Docker file. Docker file is the instruction which you give completely. You get from this image, this port, the secrets, this configuration. It's a very static file. Docker image, we have this Docker file stored in Docker Hub and all, and Docker image converts this Docker file into a runtime container, which is like a process running inside a Docker host. So that's about the Docker component engine. Then through Docker networking, as I mentioned initially, also you can communicate each other. You can have different securities and other thing also you can do. One of the important point is, by default, Docker containers are volatile in nature. Volatile, it means, let's say, for some reason, so you're not only going to lose all the code, all the files which were there in that particular container running at that instance, if you don't have the volume attached to it. So if you don't have something called as persistent volume, if you don't have the persistent volume attached to the Docker container, all the files which was there in Docker container will get killed. which get loose and erased. So if you start from new, your data will be swiped and it will start from ground zero. I mean, your code is already part of the Docker file, so you don't have to worry. But any intermediate processing file which was there will be wiped out. And Docker registry, as I mentioned, it's like you can think of like a code repository where you can version your images, the package, the compiled packages, you can pull, push, and you can share and collaborate with it. So that's about the Docker engine component. Any questions here?
No.
Cool. Moving towards next, as I briefly touched base in the previous slide, building a container image. I think it's an exciting one. And I think we always really talk about you can build your own container image and you can share it for sure. This is how generally happens runtime. What exactly you do? You have a Docker file, which is a static file which you just define. Then in Docker file, you build an image. You build an image, that image can store into some hub. Now you can have your own private hub, you can have your own public hub, irrespective wherever it's running on dockerhub.com or it's running on AWS or any other cloud or your on-prem in Nexus and all. I'll keep those storage aside, but then you build an image and that image is stored in some of the repository. And at the runtime, when you're asking Docker run command, what exactly happens is, as we touched base in the previous slide, Docker daemon given from the location configuration and pull that static image, operates on that and creates the runtime container. When it's creating the runtime container, all sorts of arguments which you give, right? So if we look into this 3 stages, any sorts of argument or environment while what you're giving, argument in terms of the environment, I mean arguments or environment file which you're giving, right? The input to it, that's all goes in the runtime here. You pass it on in the here, the Docker run command, all those get passed as an environment variable, which helps for your application perspective. Like generally, for an example, log levels, like what we do in the development cycle, you keep it like around debug or error. When you're releasing in prod, you only keep info, or let's say masking the security. Those different other use cases what you can have, or let's say the database username password, very simple, right? Any sorts of credentials. So you provide in Docker file the content, arguments, environments, and all. Override Docker file. You can also override the arguments when you're building the image, right? You can not only just provide the static, you can override it, and finally in the runtime also you can do the same thing. But in case if you, let's say, don't provide, it will by default pick into that one. So how we have, right, default values. So this will be the default values which you specify in the Docker file, but you can override when you're building the images or when you're running the image at the runtime. So that's how the general process works and how we can pass the overall arguments also, which gives you some customization part of it. This is a very insightful command. Again, I'll reiterate around it. I've tried to keep very crisp presentation today. I mean, Docker, Kubernetes are very vast domain. It's very difficult, right? So unless you go try hands-on, theoretical will only give you the concept, what is container, what is host, what is daemon. I would say even if you don't know theoretical, that's all okay. The more important thing is hands-on, right? Do as much hands-on as you can. This is a very helpful or few initial commands which you will need. I won't say this is complete sets of commands. What I'll do is, as the next step is, I'll give you the links also which you should refer. But again, the best part is please go ahead and do it. You don't have to set up any EC2, nothing, or no other infrastructure. You can do all the experiments in your laptop. So whenever you get a free time and you're very interested in learning Docker or container thing, please go and do the hands-on. There is very exhaustive documentation all available. And again, I'll share all the materials and links after the sessions. So please do more hands-on what you can do from here. So here we end our Docker part of it. Do you guys have any overall questions on the Docker? Again, I have a demo, but looking at the time, I'll pass it on that demo. I mean, the code, the demo steps and everything, I will pass it on the presentation, and which Sandeep will share with you guys, and we can discuss that. If you have any, I mean, I'm sure you guys will not able to do it by afternoon, but yeah, we can take it offline on that. Cool. What's the next container, Kubernetes? So I would say I'll skip this slide first. This one. Okay, let me start from the why. or what's the difference between Kubernetes, Docker and Kubernetes is there, right? So far, I think this is the one slide which summarizes our entire lecture of it. Very interesting slide, I would say. This is where we started our entire discussion of today. Traditional deployments, right? So old school or the old technology, how things used to work. There exactly we move to the virtualized deployment, how things can work, how hypervisory and all those things comes into the play. Then I think we sync up or we touch base very extensively around the Docker part of it. Now we are here on the stage 4, which is around the Kubernetes deployment. Now here you can see, in case of Kubernetes and Docker work together to build and run containerized application. Ideally, Docker and Kubernetes are the underlying well integrated stuff. It's not the replacement of each other. Generally, people do understand Docker is replaced by Kubernetes. That's wrong completely. Kubernetes replaced Docker Swarm. Docker Swarm is another orchestration tool which is used to orchestrate the Docker containers. What I mean by that is, let's say this Docker container, you have 40 other applications, Docker applications, which you want to build from a production standpoint, like all the networking, security, volumes, and all of the stuff. It is very difficult to set up one by one and all, right? Same what we highlighted in the last session about the cloud formation, the automation and infrastructure as a code. There exactly, Kubernetes is more like an robust orchestration, modern era orchestration with best practices like securities, different kinds of ingress controllers, different kinds of networking components. It provides on top of Docker to simplify the entire overhead of orchestration. But when it comes to this pod, I mean, there are certain jargons that change. Like here we talk about the container and other stuff. That also it's a container. But the pod in Kubernetes, what we call this is more like a pod. This blue box, gray box is like a pod. This pod is exactly the same what you have. But in order to define this pod and define to have the entire networking around it, layer around it, Kubernetes simplifies it on top of the Docker. Any questions? Because this is very important to understand how exactly it's stuff. The rest, I would say, it's very repetitive. Outside changing couple of terms, the storyline is going to be the same. Kubernetes and Docker are not two separate poles, I would say. Kubernetes is more an orchestrated enterprise orchestration way of having Docker with other complex securities and production scale best practices, what you can give around it. So going back to the first slide and just quickly scanning through the different stuff, Kubernetes is also referred as K8. K8 is an open source platform used by Linux container across private, public, private, and other stuff, which we have already run through in Docker also. Business uses Kubernetes to manage microservice architectures. Containers and Kubernetes are deployed on most cloud providers. Again, not most cloud providers, I would say. It's agnostic. You can do it in on-prem, in your machine, in your cloud, anywhere it works. As I mentioned in the previous slide also, right? And then which is ahead, third slide, the features of Kubernetes are much more larger compared to the vanilla Docker. The previous, what we refer is just a vanilla Docker. You'll see there is much more complex feature Kubernetes provides, which was the ask and the need of the organized industry, like secret and configuration management. Now, okay, you can pass an environment variable for the Docker, but environment variable also, if you're seeing the logs, it's just going to print the password as is, right? If you need some more complex, sophisticated way of doing it, provides Kubernetes, provides secrets as a different, I would say, library itself or command, which you can take care of it. Automatically bin packing, right? It can take care of all the packages and all of the stuff. Self-filling. In Kubernetes, there is something called as deployment. Like people who has some idea about AWS, it is called as auto scaling, right? Like if some node get crashed, the auto scaling will spin up another node. Similarly, functionality on Kubernetes is called as deployment, where you specify exact same thing. I need to have X version of the pods. If one of the pod got crashed, new one will be replaced. Automatically roll out and roll back. That simply means, I mean, this is a very good functionality. In DevOps, generally people use this, we studied in the last slide, which was around the blue-green deployment, right? Blue-green deployment is around when, let's say you are Amazon, right? Amazon.com.in, sorry, the website what we have e-commerce. You would see there is keep rolling changes that keep coming around it. Now, when Amazon is going to test, if let's say something failed, how Amazon roll back, right? So underneath, people use something as like a blue-green kind of stuff. So they have a running blue version, they deploy a new version of it, and slowly and gradually they move away from one version to another version. There's a small chunk of traffic. If all looks good, then they move away and then they discard the old platform version. So those kinds of other complex deployment is also sophisticated in rollouts and rollbacks kind of features, which was not possible in case of Docker. Again, load balancing, that's a simple stuff. Service discovery is more like whatever the services, networking services what you have, and the complex load balancer setup on top of the ports and all, that gets very simple, easily you can define in the way in your Docker, in the Kubernetes file itself, which was very difficult and next to impossible in case of Docker. And last is the storage orchestration. So I think we understood in the last slide also that by default, containers works in a volatile mode. If you want to make it more stateful, you have to attach a kind of a persistent volume. In case of Kubernetes, Docker also, as I mentioned, you can attach a persistent volume. In case of Kubernetes, the why storage orchestration is a very good feature compared to Docker is Docker only supports a one or two types of storage attachment. When it comes to Kubernetes, it provides multiple types of these storage, right? It can also provide a storage which can be terminated, like in volatile in nature. It can also support different cloud provider storage. It can also support on-prem different storages as a kind of a storage for your pod. So it provides much more larger functionalities, which Docker was squeezing in terms of the operational part of it. And in terms of the ecosystem, what exactly Kubernetes consists of? It consists management, it consists monitoring, logging, load balancing, security tools, support to public cloud, and open source framework. So Kubernetes ecosystem consists of all of this functionality, where some of them Docker were not able to do it. And there was a need of industry that we want. I mean, you will see industry will always look forward flexibility. I should be flexible. I will love to do what I want to do. I will love to do where I want to do. These are the three things industry will always look forward. They don't want to change themselves. They will change the technology for themselves. That's what the simple way we can define around it. So that's how Kubernetes came into the play, and it provides the things what industry was looking forward in terms of the containerization by simplifying the orchestration, different complex functionality, and providing more security around it. Moving towards the next, I'll quickly glance to, I think it's better management through. You should use Kubernetes very aggressively when you have microservice architecture. IT cost optimization. I think I don't see a very difference between Docker and all. This is a difference if you talk about the virtualization perspective. Improve scalability and availability. This is for sure boom. I mean, I will say a comparison factor between Docker as well as virtualization, because with help of deployment, load balancing, it scales as well as is highly available. Multi-cloud remains the same in case of Docker as well as Kubernetes, or difference in compared to virtualization. Last, effective migration to the cloud, same as Docker. I mean, as I mentioned, the underneath engine is more of a Docker. So a couple of points will exactly remains the same. Anything which is over and above the Docker, there you will see a better performance. Specifically, I would like to highlight this point: improve scalability and availability, which is nothing to do with your Docker application, is over and above your Docker application. Like security and networking is over and above your Docker application. There you will see Kubernetes has been very effective in nature compared to Docker. So that's one. Next, I think we already touch base on this slide. Exactly, I was coming now. Docker Swarm and Kubernetes holds a very difference. So there you can say it replaced Docker Swarm. So after Docker, people didn't realize and came with a Docker Swarm, which is like a same orchestration tool on top of Docker. Now the difference was it was more just an orchestration tool. It doesn't provide any other complex stuff around it. In case of Kubernetes orchestration is one thing out of that many things, out of those many storage orchestration, in terms of security, in terms of networking, in terms of high availability and all. Those are the many stuff which are provided along with Docker Swarm. And the best part, Kubernetes was, since it was very lightweight, as in I would say complex, lesser complex, there's a great community support also. One of the things which is very effective for any open source is community support. Even though if the tool is very good, I mean, it's not possible, but just in case also, if tool is very good and you don't have a community support, people will not very look forward to it, because in case of open source, community support is the very mandatory requirement, you will say. So Docker Swarm has its own advantage, very simplified way of doing the stuff, right? When you will go to the difference, you will say, okay, Docker Swarm is good, but I would say the biggest gap that you see is community support of Kubernetes is very higher compared to Docker Swarm. So first point, no auto scaling. As I mentioned, it was only focusing on the orchestration, not the high scale and availability. That was the killing factor of Kubernetes. Second, community. Easy to start a cluster because it's only doing one thing, which is orchestration. In Kubernetes, you're not just doing the orchestration. You have the networking, security, auto scaling. So it is difficult to start because you have to do lots of other stuff. Limited to only Docker API capabilities can overcome constraints of Docker and Docker Kube, because Kubernetes is used Docker as one of the underneath engine, but a very abstract layer on around that. That's why it supports much more larger around the APIs. Does not have a much experience with production scale deployment. Deployed scale more often. This is very correlated to the first point. It's not to production deployment scale because in production you need auto scaling, which is a missing factor. Here it's very simple because it provides much more sophisticated way of auto scaling and everything. So again, if you're having a very simple application, which is, let's say you're building it for your own small POCs and all, you can go for to Docker Swarm because it's lightweight and you can get your achieve what you're looking for. But if you're doing any complex, high availability and those kinds of stuff, Kubernetes was go to tool, and that's why you'll see a larger community support also for that. I think there was a question around how exactly the Kubernetes worked. In case of Kubernetes, this is the architecture what we have compared to the previous state architecture. The biggest difference in Kubernetes and Docker, what we see is master-slave concept. Outside keeping the binaries, the way of interacting, the way of commands on site, and other functionalities and features on site, Kubernetes works in a master-slave concept. And Docker was a single node kind of a thing. Like Docker daemon was the core, and Docker daemon decides everything for all of the slaves, which are also part of that. When I talk about the slave, the Docker application, which is a part of that same node. In case of Kubernetes, it is a master-slave concept because it's more like an auto scaling. So that's why master got split, and then there is a worker node. So this is a master which has all the brain. So that's a big difference that comes up when it comes to Docker architecture versus Kubernetes architecture. Again, there's an API server, which is in case of, if you talk about a Docker architecture, Docker daemon was the only king of doing all those orchestration and all those management. Here you will see there are different actors that come here. There is an API server, there is controller manager, scheduler, etcd, kubelet, kube proxy. Those are the different binaries that comes up. We will learn through, there are a couple of theories also we have to go through, but major difference is the role got more delegated compared to Docker. If Docker daemon due to some reason get failed, your entire Docker will get shut down. In case of Kubernetes, the roles got broke down again in microservice state. Like now API server, if you see by default also underlying it uses microservice. API server will only do its interaction. Scheduler will only do its one job. Controller manager will do its only one job. Kubelet will do its only one job. So you will see the nature of the Kubernetes architecture is also based on the microservices. So that's the larger difference what you will see when it comes about the Docker and the Kubernetes. Any questions on this one?
Sanchit, I have a question. As we have seen the architecture, right? So I have confusion since couple of last month. I just compared the normal Kubernetes working flow and when we use cloud platform, right? So is there any major difference? Like because some of the cloud platform provider just make it ready for us. We have to just select it and use it. That's it.
I think you're running with 10 speed higher than your other colleagues. So yeah, I'll make it very short. First of all, there comes a difference. Okay, the moral of the story is there is a difference. For the rest of the people, for them who is very new to the Kubernetes architecture, I'll try to explain in that fashion. You will always try, right? Across colleges also, you will always try to build your own curriculum, which is very effective for your students, which is very simple, and people can learn and adapt, as well as the modern stuff, right? Same goes like anything, not just curriculum, even for other mobile devices, if we talk about. End of the day, what you're going to do with mobile, you're going to make a call, you will search, you will surf internet, you will do WhatsApp, you will check your emails and other stuff. If you take your mobile devices across Apple, XYZ, all provides the same functionality. It's the way, the effectiveness, the optimization of infrastructure, the cost, and sustainability. These are the couple of factors which you always see when you're buying any electronic devices or you make any calls across the different competitors. That is the same concept what Sandeep just mentioned about it. For sure, the answer is yes. Each cloud partners, or since first of all, we went in the first slide also, Kubernetes is an open source. Each cloud providers provide Kubernetes in their own way. Own way in terms of the way to optimize it. Optimize this functioning or managing this functioning. Own way in terms of the networking, right? Now, if I talk about, since I'm more into Amazon AWS, for sure you're going to hear AWS stories only from me. In case of AWS, you will see Kubernetes master, the same concept. I mean, the story remains the same in case of AWS also. There is a master, there is a slave, master and the worker node. In AWS, Amazon provides called as Elastic Kubernetes Service, EKS. This master is a managed service. Like how we had Lambda, and I spoke about it. In case of Lambda, the server is not visible to you. Similarly, in Kubernetes, in AWS, this master is not visible to you. There is no service running into it. It's completely managed. Amazon takes care of entire functioning of Kubernetes master. So the whole storyline is you're only responsible to write your own application Kubernetes code. That's the best part, right? You don't have to worry about the networking. You don't have to worry about all the master and controlling and wiring. You only take care of this pod, the deployment file and the pod. You only worry about your business application. There exactly the difference comes up from each cloud to another cloud. They try to simplify how each their end user should look forward. The cloud always will look forward is simplifying how their end user should work on the cloud and minimizing the overhead which a person should go. So there exactly the difference will come up in couple of components, couple of names, and the binaries when you compare the open source architecture versus what AWS provides versus other cloud. Does that answer your question, Sandeep?
Yes. So it means that the things that you are talking about, scalability and all that part. So those components who are required the scalability and all that, they're completely managed by service provider, I think.
No. I would say partially yes, not completely. So scalability is again the biggest scalability as an end user to me is a pod.
Okay.
Because that holds my business application. I don't care whether my master is scaling or not, unless it gets my job done.
Correct.
Right? So I really don't care. I mean, honestly speaking, in this entire architecture, I really don't care about this block. I don't even care about the network plugin. That okay, what kind of you're using Funnel, you're using WaveNet, or you're using CAdvisor, kubeproxy and all. As a business user or as a technical person, I will only focus on my pod. Is my application up and running? Is my application is giving available for my end user? Is my application is secure? That's what you will always look forward, right? That's exactly is what cloud vendor is asking you to do. You only worry about your business application. Don't worry about all of this stuff. Don't worry about is your API server scaling or not, or which version of API server are you using. Don't worry about the network plugin, which one you're using, or other stuff, right? Or how this is getting interacted with your worker node and all. You only worry about the pod which is running, which is your business application. Whether that business application scales or not is up to you. Kubernetes is not going to take care, because let's say for a very simple example, as I mentioned, deployment, right? In Kubernetes, you will be using the term as deployment, auto scaling in general term. If you define one only node for auto scaling, it won't auto scale. Even though Kubernetes provides the functionality of auto scaling, you don't configure it the right way, then that's your problem, not Kubernetes. That's why cloud partner says that, okay, you focus designing as per the best practices, as per your business requirement. Don't worry about the other operational overheads here.
Okay, got it.
Good question. Yes, that is true, ideally, but that is one of the reason, right? That as I was talking about, if master node goes down in a normal setup, it's a brain. I mean, generally in a human thing also we talk about if your brain is dead, you are legally dead, right? Even though if your other organs are working, your heart is working, you are legally dead. Similar is the concept of Kubernetes also. If a Kubernetes master get for some reason, someone intentionally, unintentionally, or it got crashed, there's no use. I mean, this will they don't even know what they want to do. It's this is the master is driving them. That's fine. That is one of the reason also Amazon provides Kubernetes master as a managed service. So if something goes wrong, Amazon takes care gracefully at their end rather than we figuring out what went wrong and why it went wrong. So that's the bottom line story why AWS or cloud, I mean AWS provides Kubernetes master as a managed offering. Does I answer your question? Cool. Okay. Then again, I'll try. I think we are already over 15 minutes. So I'll try to quickly cover up Kubernetes as we spoke about. There are two kinds of nodes available, main components, uh, master and slave, like master node and Kubernetes node. In master node, you have API server, you have controller, scheduler, etcd, those kinds of stuff. API server, again, equivalent to Docker, the client which allows you to interact with the Kubernetes. You can run, you can do whatever you want. So just give me a minute. So you can run Kubernetes commands and other stuff. So that's the one. Controller is the one which keeps a watch, right? That okay, uh, the state of the cluster, the changes in it. So it's a watchman kind of a guy in simple words, right? Lack of term, which keeps a view around it, how things are going and other stuff. Scheduler is more like deploying, right? Let's say you want to schedule something. For a very simple example, I mentioned if one of the pod goes down, who's going to, I mean, Kubernetes or your file is not going to do. Scheduler knows it that, okay, hey, someone has given me, let's say, 3 replicas of my pod should be running. Currently, it's only 2. So controller will know that, okay, one got died. Controller will tell scheduler deploy one more pod because the instructor has asked us to make it 3. So that's kinds of stuff. etcd is more like a, I would key value kind of. So that was about the master. In case of worker nodes, you have kubelet. Kubelet is responsible for starting and stopping the containers. So with help of kubelet, you get different idea. So let's say, I think Ravi asked a very wonderful question. What happens if a master node dies? Let me ask you a reverse question. What happens if your worker node dies? Master, always master never work, right? Worker is the one, or the slave is what you will do the job. What happens if your worker node itself dies? Two things. When the worker node dies, how even master know about it? Because in case of Docker, it was the same node. Here, there are two different nodes are there, right? Master and slave. So that exactly kubelet works as a heartbeat. It is like an agent which is installed in Kubernetes node, which gives all the information to the master in a very simple language, whether it's how the Kubernetes node is performing, how the application hosted in performing, or is the node working fine, heartbeat, and all other stuff. Kubelet is the one which is performing the action which is given by the master or informing back to the master how things have been working. So let's say if something goes wrong in a worker node, kubelet will not able to respond back to the master and master will assume that, okay, that worker node is died. It can be reverse of it also, right? Let's say, as I mentioned, this is all an virtual machine, EC2 instance. Let's say for a very simple example, your kubelet got crashed in EC2 instance. Your EC2 is working fine. Your all the Kubernetes worker node component like kuproxy, cAdvisor, all those working fine. Just the kubelet died. Still, master will consider that node is done for me. It's not available for me. So unless and until you log in into that worker node and start your kubelet, then only all the functionality are working around it. So as I mentioned, the same example, right? If your brain is not responding to your body, even though your heart is working, your eyes are working, your other working fine, other kidneys are all working fine, lungs and all, it will not be effective unless kubelets comes into it. So that's true for the worker nodes. So kubelet is very important. Kube proxy is more specifically from a networking perspective. So if you want to define any sorts of networking or wiring stuff, right? Security is around it, that okay, this should work from this particular IP addresses, from this particular port, or those kinds of stuff, where kube proxy comes into the place. Pod. Pod is simply exact and smallest thing where your application is going to run. So if I talk about pod here, this is a pod where your container, Dockerized container application is going to run. That is called as a pod, the smallest unit around it. C-Advisor is like an agent built into the kubelets that collects information about the resource utilization to the master. In terms of that, okay, do you have more space that you can deploy one more app to it or not? Those information has been given by the C-Advisor. Again, as Sandeep rightly mentioned, you will see the generic architecture remains the same. Things like networking plugin or C advisory is very customized based on different versions of Kubernetes offered by the cloud vendor or the other vendors also. So Kubernetes are not just only offered by the cloud vendors. There are other vendors that offers Kubernetes on-prem system. Each one has customized it to make it more effective and operationalize, minimize the operational overhead. But this is the generic architecture. If you know this architecture, you can easily connect the dots with any other offerings that are provided in the market. So another terms, as I'll quickly scan through, pod, which we talk about the smallest unit. Deployment, I mean, talking about deployment from a lot, which is used for auto scaling, horizontal scaling, not vertical scaling, it's horizontal scaling. That is increasing the number of pods based on what you have given. Services is from the networking perspective, like how we, if you want to open a particular service, right? You want to build a kind of an API and open an endpoint, define an endpoint and give it to your end user. That endpoint definition is defined in service. There exactly it helps. It's similar in a AWS setup. It's similar like a load balancer for an simplicity. Labels is like a metadata. Selectors is like, let's say, you want to deploy a particular pod on a very particular worker node because of some XYZ reasons or infrastructure constraints, then selector via selector, you can say that you can deploy in the specific node itself. Ingress, ingress is again the networking stuff where you define how exactly your node should work, like all the wiring, security groups, the firewall rules. Same what you can do in ingress, you can define which port can interact on which particular API or which external world can interact to a particular API on which port and in which endpoint. Those kinds of ingress configuration also you can give here. And again, you can also make any endpoints public and private. That is also being taken care by the ingress. So that's all what I have from today's session.